Okay, before we get into this too much, I want to show you how you can maybe do some means or standard deviations of probability distributions just a little bit quicker. What you can do is go into your list and type in the number of possible outcomes or all the possible outcomes into list one. In list two, you can put the probabilities. Just make sure that you convert each of these percentages into decimals. Okay, go into the one var stats that we've used before, hit enter, but behind that put L1 comma L2. Okay, I found L1 by hitting the second button and then followed by the number 1. The comma button is right above the number 7. Then I hit the second button and then hit the number 2 and L2 shows up. If you hit enter, X bar should show up, and I think it's roughly what, 2.53 or 2.5. And the standard deviation is also going to show up to that distribution. It was 1.42. Okay, so just another way to save you some time. You can do that with your calculator rather than doing it by hand. Okay, binomial probabilities is the focus of this one. A binomial experiment is a experiment where there is a fixed number of trials that is denoted by the letter n, the lowercase n. So trials might be the number of times I shoot a free throw, say like n is equal to 10. The number of trials are independent and repeated under identical conditions. Each trial has two outcomes, success or failure. For each trial, the probability of success P remains the same, and the probability of failure is 1 minus P, which is equal to a Q. The central problem is to determine the probability of R successes out of n trials. So maybe R is equal to 7, meaning that I'm going to get 7 out of 10 free throws made. Okay. The sharpshooter takes 8 shots at a target over long term. She hits the target on 70% of her shots. Find the probability that she hits the target exactly 6 times. So success would look like hitting the target. Failure would be missing the target. Probability of success, or P, is 70% because we've seen over time that she hits the target 70% of the time. Her probability of failure is 1 minus that 70%, or 30%, or 0.3. The number of trials, she's going to take 10 shots, and we're looking for the probability of her getting R is equal to 6 successes, or 6 hits. And the binomial formula is P parentheses R, where R is the number of successes again, N is the number of trials, P is the probability of success on each trial, Q is the probability of failure. Oftentimes you'll just see me put a Q there, and then R is the number of possible outcomes or successes. Now R has to be 0 or less than n. It can't be anything bigger than the number of trials, and it can't be a negative number. I'll show you how to do it a couple different ways. Your calculator, and also there's this table on page A10 in the back of the book, and you'll also get access to that and all your different quizzes and tests and things like that. So recall the probability of she hitting 6 trials. So here I put it into the formula. This right here is the work for 8 combination 6. You can use your calculator for that. 0.7, so there's your probability of success raised to the 6th power. Makes sense that we have 6 successes at that rate, which would leave us with 2 failures at the rate of failure. And that all works out to be about 0.296. So the probability that she gets 6 out of 8 shots hitting the target is about roughly 30%. And here's how you can pull that off by looking it up in the table. So again, you look at that table. On the top part here, you're going to have a bunch of different probabilities listed. You're going to look for the P equals 0.7 because that's the probability that she hits the target is 70%. Your grouping on the side, you're going to look for the grouping of n is equal to 8, and you're going to see a bunch of different r's. Now there's going to be 9 of them because it's going to go from 0 successes, 1 success, 2, 3, 4, 5, 6, 7, and then finally 8. Okay, since we're looking for r is equal to 6, under the 0.7 column, look that up, and there's the 0.29 that we would have got with our formula, or that we didn't get with our formula. Okay, so this is kind of what it looks like as a big zoomed out shot. So up top here are all the different probabilities of success. Here's our grouping of 8. It's got 9 of them because 0 is included. If you look at 9, it's got 10 of them, or it will have 10 of them. I guess it gets cut off a little bit because there's 0 through 9. Okay. So cross-reference those, and there's our answer, 0.96. Okay. Where the table really is going to help us out is when we have probabilities of things like here, where it's at least 2 makes, or at least 2 hits. So the probability of at least 2 would be 0 or 1. So I'm going to look up in that same table, I'm going to find out the probability that is given me. P is 0.25. So here I'm going to look under the row of 0.25, or rather the column of 0.25. N is equal to 4. So I'm looking for the grouping of 4. And I can just go grab the answer for 0. And I can grab the answer for 1 and add them up. So the probability of at least 2 is 73.73%. Not percent, but exact. So here, if you were to go and you were trying to find exactly 4, okay, you're going to go to your table. Got to read through here real quick to see how many we've got. Our n. N is equal to 12. Okay, we want exactly 4 are cured, so success would be cured. So R is 4. The probability that the patient is cured is 0.3. 0.7 means that they're not cured. You could run that through your formula, but I'm just going to open up the back of the book and I'm going to look at that table. Yeah, so I'm going to go to the column that's got 0.3. I'm going to find the grouping of 12, cross-reference that with, or not cross-reference, 0.3. I found for R is equal to 4, 0.231. Okay. All are cured. Okay, so I'm going to still look at 12. R is, wow, well, I guess 12. P is still 0.3. Q is 0.7. So I'm going to look at the last one in that row, and it's 0.000. So basically, not going to happen at all. Okay. 12 patients, 0 are cured, 0.3 success rate of them being cured, 0.7 of them not being cured. I'm going to look at 0, and I've got I believe, let's see, 0, 1, 4. Okay. Maybe the formula would be just as fast, maybe not. But when it comes to things like this, where it's at least 6, now there's 12 patients. R is actually all of these numbers. I would still look under the 0.3. What's going to happen is I'm going to take those decimals and I'm going to grab it from the book. This is what I got: R 6, 7, 8, 9, 10, 11, 12. I'm going to end up adding all those up to get my answer. So it's much easier to take a peek at that table, get my decimals that way, and get my 0.117. Do it that way instead of running through the formula, what looks like 7 times. Okay. So you're going through the homework and you're looking at, there's some common English expressions, phrase like at least, at most, greater than, less than, things like that that correspond with the inequalities that might help you out. There is a way to do this in the calculator, obviously. I'll go to page 241 for that, and here's your assignment. I would run through as many of those as you need to. The table is great, but it doesn't work always when you've got a probability that's something like this. Because the table will go with 10% and then jumps to 15%, but it doesn't have p is equal to 0.12. That table is really only going to work when you got the probabilities that are listed above. So again, give that a shot. I would really stress this. Do some of the homework, get it figured out, come with questions to class, because there's going to be some questions I'll be asking you.